We will start in a couple of minutes. Meanwhile, just let me know if you can hear my voice, if it's audible. Thanks, Anshuman. So today's topic is relatively easy. So once you get the hang of it, you should be able to solve almost all the questions on it. And as we will go through this class, you'll also notice that most of the questions follow a similar approach, a similar pattern. And that once you have mastered it, you should not have any problems with. So we'll go through it fairly quickly. And I'm hoping that this class would be shorter than the other ones. We'll see how it goes. But in general, because the topic is easy and there aren't a lot of difficult concepts, so let's see how it goes. So we'll start with this, the concept of time and work. And there can be other questions also based on it, but most of them follow a similar pattern. So let's start with the first question, and here we'll show you the method. A completes the work in 10 days and B completes the work in 25 days. How many days will they take to complete the work if they are working together? Okay, so this is very basic question. A lot of people have done similar questions at junior, at high school level as well. And the way it is taught in schools is, and it's a proper method, is that if A takes 10 days, then A's 1 day work is equal to 1 by 10. And if B takes 25 days, then B's 1 day work is 1 by 25. So if they work together, they will do 1 by 10 plus 1 by 25, or 7 by 50 of the work. Okay, so in 1 day they will do 7 by 50 of the work. So the total time that they will take to complete the work will be 50 by 7. Okay, or 7 days. So that's the traditional way. And I expect most of you know this. If you don't, just revise a bit of the high school stuff. The difficulty with this is that it's a bit tough to implement. You get into fractions, you need to add fractions and all that kind of stuff. And many times it becomes a bit cumbersome to calculate. And that's why there is this other approach which most students appearing for CAT and similar competitive exams follow. And will learn that. And then you can apply that. So what you do here is that A completes a work in 10 days, right? And B completes the same work in 25 days. So you just assume a unit, as in how much work they do. For example, it will become clear with examples. I'll assume that the total amount of work is, say, I can assume any number. So I'll assume 100 units. So I'm assuming that the work involves 100 unit of work. So when A completes the work in 10 days, that means A in 1 day does 100 by 10 units. So A does 100 units in 10 days. So in 1 day, A does 10 units. So A's working capacity is 10 units per day. Similarly, B completes the entire work in 25 days. So in 25 days, B completes 100 units of the work. So in 1 day, B completes 100 by 25, or 4 units of the work. Okay. So how does this help us solve the question? So we have just assumed 100 units. We can assume any number. So I assumed 100 because 10 and 25 both divide 100, and it will make my calculation easier. Then I know that if A does the work in 10 days, so A completes 100 units of the work in 10 days. So in 1 day, A does 10 units of work. And if B completes the work in 25 days, in 1 day, B completes 4 units of work. So when A and B both work together, how many units they'll complete? So these things can add. A does 10 units, B does 4 units. So A and B together do 14 units per day. And to complete the job, how many units need to be done? 100 units. So when they work together, they'll do 14 units every day. So to do 100 units, they'll take 100 by 14 or 50 by 7 days. Okay, so the advantage with this method is that you can simply add the units. 10 plus 4, 14. You can assume the number here. if I felt 120 was a better number to start with, I would have started with 120 units, because I assumed 100 because 100 was divisible by 10 and 25. So that makes all the calculation easier. It makes it faster. You can do most of it mentally, and that will help you increase the speed a lot. So if you have understood this concept, then all the other questions you can solve. If you haven't understood this concept, then you would find it difficulty. So I'll do one more question, but meanwhile, if you haven't understood, raise your voice, and then I'll explain it a bit more. Let's look at a second question. A and B can together complete a work in 12 days. So when A and B together work, they take 12 days. And B can alone finish it in 30 days, and B alone can do it in 30 days. So how much time would A alone take to complete the work? I won't go into how you would have done it with the traditional method, but let's see how we discussed right now. What I can do here is I can again assume how much work is there, right? So I have 12, I have 30. So I need a number which is divisible by both of them, which would be easy. So I'll just assume 360 units. So I'm assuming that the total work is 360 units. Okay. So when A plus B work together, they complete 360 units in 12 days. So in one day, they do 30 units of work. And when B works, he does 360 by 30 or 12 units per day. Okay. So A plus B, the work done per day is 30 units. When B works alone, the work done is 12 units. So when A works, how much work will he do? 30 minus 12 or 18 units per day, right? Because this is additive. So if combined they do 30 units and B does 12, A does 18 units per day. So if he had worked alone, he would have done 18 units. So to do 360 units, he would have taken a 360 by 18 or 20 days to complete the work. So this is the advantage. You can do all of this mentally also. You don't need to write anything or do anything. Yeah, you can just by reading the question, you can do most of it mentally, and people who have practiced it a bit are able to come up with the answer with these seconds. The question when it comes won't come in this form. It would be slightly more complicated, but being able to do this in seconds is very helpful. Okay, let's see a few more questions. And I'll keep reducing the amount of working I am showing as I go through so that you get some idea also how it is. So A and B complete the work in X days and 1.5 X days respectively. What is the value of X if they're working together complete the work in 12 days? Okay, so this is a slightly different flavor. Same question, but it's a slightly different flavor. So let's see how we could have done that. Could we have used the same method, or could we have used? Do you need to do something different? Let's assume the units of work. I see 12. I see 1.5. So I would choose something which is 12 into 15. Seems like a good number. So let total work be 180 units. So I have assumed total work equal to 180 units. Okay. So they work together. They complete it in 12 days. So when working together, they do 180 by 12 units per day, right? Or 15 units per day. When A works alone, he takes X days. So amount of work he does in one day, 180 by X. And when B works alone, he takes 1.5X. So when amount of work done when alone, 180 by 1.5X. So in one day, A does 180 by X, B does 180 by 1.5X, and together they do 15 units. So using this equation, you can solve for it, right? So now you have got an equation. You just need to solve for it. 1 by X, if I take common, you'll get 180 by 3 by 2 or 120. So 1 by X, this is 300. So X becomes equal to 300 by 15 or 20. So X is 20. So they complete the work in 20 and 30 days respectively. So you can solve it this way fairly quickly. Okay. Just a second. Just a second. I think some people are finding it difficult to see the video, which I don't understand why. I'll just reply to them in a quick second. So this is how you can solve this question. Let's see the next question. A, B, and C complete a work in 60 days, 30 days, and 20 days respectively. How much time would it take for them to complete the work if working together? Again, Same pattern, exactly same. Now I won't even write much. I'll assume 180 units. So total work is 180 units. A does in 60 days. So A's daily work is 3 units. B's daily work is 180 by 30 or 6 units. And C's daily work is 180 by 20 or 9 units. So A in a day does 3 units, B in a day does 6, C does 9. When they are working together, the work is 3 plus 6 plus 9 or 18 units per day. So when they work together, they work 18 units per day. Total work we have assumed is 180. So the time they will take will be 10 days. Okay. So this is the advantage of this. Uh, is this clear? Is this new? Is this very easy? If it's very easy, I can jump to more difficult questions. Uh, So I'll just take a pause here because I've done 4 or 5 questions fairly quickly. So I'll take a pause just in case you have some doubts or something you are not able to follow. Because we have time and we just have to cover this one concept properly, which we'll use to solve all the questions. So if your understanding is good till here, you should be able to solve other questions also. If it's not good till here, then you will find it other questions also difficult. Sai, I don't understand what VE means. So I'll move on to the next question. A and B can do a piece of work in 36 days. A different version. We'll approach it exactly the same way. A and B do a piece of work in 36. B and C do the work in 48. And A and C can do it in 72 days. So we have known 2 at a time how it works. So when A plus B work together, they take 36 days. B plus C, they take 48 days. And then C plus A, they take 72 days. Okay. Let's assume the amount of work 36, 48, 72. I'll again assume that total work is 360 units. Okay, because these numbers seem to be divisible. I can choose something bigger also, but I'll choose this one. Okay. So when A and B are working together, 360 units they do in 36 days. So per day they do 10 units. Okay. When B and C are working together, per day they do 360 by 48. 360 by 48 and both numbers are divisible by 18, 3 and 20. So they do 20 by 3 units per day. And when C and A work together, they do 360 by 72 or 5 units per day. So now we have 3 equations, 3 unknowns. We can calculate how much each would day per day, but we don't need to do that also, because the question that is asked is how much time would it take for them to finish the work together. So if we know how much units they will do if they work together, we can calculate that. So we just add all these 3 equations. If you add these 3 equations, it becomes 2a plus b plus c is equal to 15 plus 20 by 3 or 65 by 3, which means a plus b plus c together, they do 65 by 6 units per day. Yeah, so they do 65 by 6 units per day. And using this, you can simplify. Now you know that they do 265 by 6 units per day. Total number of units needed is 360. So 360 divided by 65 by 6, and that would be 360 into 6 by 65. Okay, unless I made a mistake. The numbers seem a bit weird, so I'm just thinking if I made a mistake something somewhere. Yeah. So this is it. So this is the number of days it would take them to do it by themselves. And then you can simplify and get 720 by 13 days or however many it says. Okay. This comes somewhere close to, I think, 32, 33 days. somewhere close to that. So whatever be the number, but you need to know the method. So is this one clear? So if this is clear and it seems to be, then just try this one as well. All of these are easy. I have a few difficult ones later on, but try this one. I want to get some sense on how people are reading. So can you do this one mentally almost? Like within 90 seconds, you should be able to get the answer. Even if you don't have a pen and paper, you should be able to do it. Some people are spotting mistakes in the previous one. So maybe I did made a calculation mistake, but that's fine. You can adjust for it. Try doing this one. I will slowly start writing the answer here. A and B can do it in 20 days. B do it 30, and C can do it in A can do it in 20, B in 30, C in 40. So overall, let's say 600 units of work are to be done. So A's speed is 30 per day. B is at 20 per day, and C does it at 15 per day, right? They begin together and work for 5 days. So in 5 days, they're able to do 65 into 5 or 325 units of work, right? And then B leaves. So now the remaining 275 units of work is done by only A and C, who do combined 45 units. So 275 by 45 will be the answer. And whatever that number comes to, if you do it by 55 by 9, or roughly 6 point some days. Right? So this is how much time they would take to complete the work. So again, it's fairly straightforward. You should be able to do this kind of question almost mentally. If you get such a question, you should not miss out. It is a full toss. Any day, the message should go to you that I need to do this question because others will be doing it. However complicated be the question, others will solve. So if you are not doing such questions or any question related to this topic, you are missing out on stuff which others will not miss out on. There are questions related to pipes also. They are also done similarly. Let's say, so pipe can fill the tank in 40 hours. Another can fill it in 60 hours. The only difference is that there is a concept of negative work also. Negative work generally doesn't come, like it's not like somebody will do negative work. But in pipes, you can have such concept also, that there is a pipe which is emptying the tank. So how much time would it take to fill the tank if all pipes are open? So again, the approach will be similar. A pipe can fill the tank in 40 hours and B can fill it in 60. Another one can empty in 90. So let's just assume a number. You will assume something like, what makes sense? I'll assume 360 units of water is needed to fill the tank, okay, or empty it. The tank can hold 360 units of water, which means pipe A fills it in 40 hours. So it means 9 units per hour. Pipe B fills it in 60 hours, so 6 units per hour. So this is their filling speed. And pipe C empties it in 90 hours, so 4 units per hour. Okay, so you combine these three. So what we need is A plus B minus C, because C is emptying and A and B are filling. So the rate at which water will be filling when all three are open will be 9 units in plus 6 units in minus 4 unit out, or 11 units in total. Using this, the number of hours is you need 360 units, so just 360 by 11, or whatever it comes to, 32 point something hours that you can solve. So again, fairly straightforward. You should be able to just a second. You should be able to solve for this question. Okay. Similar question, slightly more trickier. Cistern has three pipes, A, B, and C. A and B can fill it in 3 hours and 4 hours respectively, while C can completely empty the cistern in 1 hour. So let's assume total units of liquid are 120. A can fill it in 3 hours, so A fills 40 units per hour. B fills in 30 units per hour. And C empties at the rate of 120 units per hour because it can empty it in 1 hour. The pipes are opened in the order at 3 p.m., 4 p.m. and 5 p.m. respectively. So if you open it at 3 p.m., you have opened A. So A is filled 40 units between 3 p.m. to 4 p.m. And then between 4 p.m. and 5 p.m., A fills in 40 units and B has also been opened. So B fills in 30 units more. So by 5 o'clock, already 110 units of liquid are there. 110 units of liquid are there. Post 5, all three taps are open. So post 5, you have 40 plus 30 minus 120 or minus 50 units per hour going out. And it already has 110 units. So how much time will it take after 5 o'clock to get empty? It will take 110 by 50, right? Or 2 1 by 5 hours. Or 2 hours and 1 by 5 into 60, 12 minutes. So post 5, it will take 2 hours, 12 minutes to get empty, or 7 hours, 12 minutes. 12 p.m. it will be empty. So similar concept, similar thing to apply. There's nothing very fancy here. You should be able to solve all these questions once you have known this idea. Just there is one idea which you need to be comfortable with, and then you can do all these questions. Any people who are watching, listening, any feedback, is it clear? Is it not clear? Can we jump to difficult stuff now? One or two at least. Want to do a few difficult questions which are not as straightforward, so that you get a flavor of what kind of questions to expect also. Cool. So I'll just get to the slightly more trickier ones. So these questions are slightly longer versions. The one that is there on your screen, it's not difficult. It's not more difficult than what was there earlier, but it's just it has more. It is slightly more longer. The methodology will remain the same. Work done by 4 men in 12 days is equal to work done by 6 men in 10 days and is equal to work done by 8 children in 9 days. Man, woman and child working together take 10 days to complete a particular job. In how many days will the same job be completed by 2 women and 5 children working together? Okay. So 4 men working for 12 days, 6 women 10 days, and 8 children 9 days. They all do the same amount of work. Okay. So let's assume this is a certain amount of work. And that's what would make this question here. So I see 12, 6, 9, 8. So I'll use a number which divides these numbers. So let's say I'll choose, they do 720 units of work. Okay. So 4 men in 12 days do 720 units of work. So how much one man does in one day? He does 720 by 48, right? 720 by 48. Or 30 by 2, 15 units. So one man does in one day 30 units. One woman one day does 720 by 60 or 12 units. And one child in one day does 720 by 72, 10 units. The link is live, right? I'm getting a lot of messages today that they are not able to watch the video. So is somebody facing that problem? that's actually bugging me a bit. So we know the man does 15 units of work, the woman does 12 units, and the child does 10 units. So now we want to know in how many, when these three guys work together for 10 days, they are able to do a particular job. So when they work together, one man, one woman, and one child for 10 days, how many units they'll complete? They will do 15 plus 12 plus 10, or 37 into 10, 370 units. So the total work is worth 370 units. And now we want how much time would it take for 2 women and 5 children to do that work. So 2 women and 5 children in one day, they do 24 plus 50, 74 units of work. And they have to do 370 units. So how much time would it take? 5 days. So the total answer will be 5 days. So this is a slightly longer version, exactly the same question. It should not trouble you at all. And you should be able to do this also fairly quickly. You might need to put pen to paper, but the calculation should be fairly simple, and you should be able to get the answer within 60 to 90 seconds. So this is actually the same question. I think we have repeated it. This one is a bit tricky. I think I've picked it out from previous mocks or something, but this one is not straightforward. Now, and this is the kind of flavor you can expect in the exam, which won't be very straightforward, but still similar concepts. So A, B, and C can finish a job working alone in 15, 20, and 25 days. Okay. But so when they work alone, they finish it in 15, 20, and 25 days. But when they work with someone, their efficiency reduces by 30%, 20%, and 50% respectively. So, and none of them are allowed to work for 3 consecutive days. What is the maximum possible fraction of job they can complete in 4 days? So A, B, and C, there is their productivity, and then there is their productivity when they work with someone, which is lesser. So with someone, their productivity is lesser. And then we are told that 3 people, they cannot work 3 days consecutively. Neither of them can work 3 days consecutively. How can we get the maximum amount of job done in 4 days? That's what the question is. Now let's start with what we have studied. So we have that they can complete a job working alone in 15, 20, and 25 days. So as we have done previously, let's assume a number. So we have 15, we have 25, we have 20. So we'll assume 750 units of work. Let's say total amount of work they do in 15 days is 750 units. So working alone, A does 50 units per day. B does, we should have chosen 1500 actually. So I'll change it. I'll change it to 1500. And that you can do. If you move ahead in the question and you see something you have assumed is not making sense, you can quickly change it. It was making sense, but even I want it much more easier. So now A has 100 units. B has 75 units. And C has 1500 by 25, 60 units. So when they work alone, they do this much work per day. But when they work with someone, A's productivity reduces by 30%. So A does only 70 units per day. When B works with someone, B's productivity reduces by 20%. So B becomes 4 by 5 into 75, or does 60 units per day. And C reduces by 50%. So C does only 30 units per day. So this is their productivity. Now you have to design how can you get the maximum work out of them, right? And here you will need a bit of trial and error. What we do know is if A, B, and C work together, that's good for us, right? And out of 4 days, I can get that done. Like I can ask A, B, C to work together on the first day. And then maybe I can ask them to work together on the second day also. And then the third day, I won't have anybody to work because all of them would need a break. They have worked for 2 days. And then on 4th day, I can again ask ABC to work all 3 days. So that is one possible scenario. and you'll have to check how much it comes to, how many units of work gets done. So all three working together, you will have to choose these numbers, 70, 60 and 30. And you get 160 units each day, and total you get to 480 units. So that is one possible scenario. But here I am wasting one entire day where no work is getting done. What if I try to get somebody in there? So I can say, okay, A, B, C work together, but then A has the best capacity working alone. So I'll want A to continue to work the next day, and then B and C can work the third day, and then fourth day A, B, C all work. This is also a possible scenario. And if we do it this way, the first day, since A, B, C are working together, we choose these numbers and we get 160 units in first day. Second day, A is working alone, so we get 100 units from A. Third day, B and C are working together, so you choose these numbers, 60 plus 30, 90. And then final day again, we get 160. Okay, and this totals up to 320, 420 plus 90, 510 units. And if you try two more combinations, you get to this, that this is the best combination possible. So the best amount of work that I can get under these criteria is 510 units. And 510 units, so the amount of work that I can get done maximum is 510 out of the total of 1500, right? Which is 51 by 150, or if you simplify it further, dividing by 3, it is 51 by 150, or simplified further, it comes to 17 by 50. So that's the maximum amount of work you can get done in 3 days. Is it clear? So this is one of the more difficult question, one would say. If you can figure this one out, this won't be easy to solve under an examination setting, because you'll have to try different combinations. You need to ensure that you don't make mistakes, as in when you are adding B and C, then you should know that B and C are working together, so choose these numbers. When A is working, he's working alone, so choose these numbers. When A, B and C are together, again go to these numbers. So that you'll have to try. So in the exam setting, it might not be very easy, but it's a good question, and you still have to stick to what you have studied, and that method still applies. You don't need to do anything more fancy or funky. Assume a certain amount of work and go ahead and solve it. This is a slightly different version of the same questions which we have done earlier. Here the only difference is that pipes are not running continuously. So in the odd hours, which is first, third and fifth, pipes are running for 40 minutes, and second, fourth, sixth, pipes are running for 50 minutes. So we need to know when tanks will be full. Okay. So there are 10 total pipes. They can fill a tank completely in 30 hours. We have opened up the 5 pipes. Okay. So let's assume similar thing. 30 hours, 10 pipes. So total volume is 300 units. So one pipe in 1 hour fills 1 unit. That we know, because 10 pipe in 30 hours fill the entire thing. Now 5 pipes are filling for 40 minutes. How much will they fill? 5 units into 4 by 6. Because they're open for 40 out of 60 minutes, or they'll do 10 by 3 units. And then in the next hour, they will do it for 50 minutes. So 5 pipes into 5 by 6, or 25 by 6 units. So in total of 2 hours, they are able to do 45 by 6 units. Right, 45 by 6 units. So per 2 hours, they do 45 by 6 units. This continues for 10 hours. So in 2 hours, if it is 45 by 6 units, in 10 hours, they will do 45 by 6 into 10. Okay. Or I think this cancels, right? 15, 2 and 5. Total of 75 units. Yes. 75 units they'll have done in 10 hours. So the amount remaining, which was, so the initial tank was 100 units, and now you have done 75. So the amount remaining is 100 minus 75, or 25 units. And at this stage, we have pulled in 7 more pipes. Okay, so if you have 7 more pipes, then total amount of time, uh, the units that I start filling every 2 hours increases from 45 by 6, which was for 5 pipes, to 45 by 6 into 12 by 5, because now we have added 7 more, so it becomes increases by 12 by 5. So every 2 hours I would be doing 18 units. So using this, you can calculate. You need to do 25 units. So 2 more hours, you would have done 18 more units, and that would have left with you with 7 units. And in 1 hour, the 40-minute hour, you do how much, and so on. You can continue to calculate, and you'll get that fairly easily. It's not very tricky to get there. So there are more such questions, but I would like to leave some of them for you to work on, because they're all fairly similar. There isn't anything very tricky in any of these questions. But, so which one should I pick? Let me just see. So let's see. I will just do this one, which is straightforward one again, but needs a bit more thinking. It's not that straightforward. So there is Arnav who can complete 1/4 of a piece of work in 5/12 of the time taken by Vern to complete the entire work. If they together can complete the work in 15 days, then in how many days can Bhavan working alone complete the work? So let's say Arnav does X units per day. Okay. So I've assumed Arnav does X unit of work per day. So Arnav can complete 1/4 of a piece of work. And let's assume that the total amount of work is, what do we assume? We'll assume some good number, so 600 units. Okay, so total amount of work is 600 units. Arnav does X units per day. So Arnav can complete 1/4 of piece of work, that is 150 units, in 5/12 of the time. So how much time will Arnav take to do 150 units? 150 by X, right? And how much time would Bhuvan take to do the same work? So Arnav does X units per day. Working together, they are able to complete it in 15 days. So working together, Arnav plus Bhuvan do 40 units. So Bhuvan will be doing, where do I write? I'll write here. So Arnav does X units. Together they do 40 units. So Bhuvan does 40 minus X units per day. Okay. And now what is said is Arnav can complete 1/4 of a piece of work. So 1/4, how much time will it take? 150 is the number of units, and since he does X, he will take 150 by X. In 5/12 of the time taken by Bhavan to complete the entire work. So 150 by X is equal to 5/12 into how much time Bhavan would take. How much time would Bhavan take? 600 units at 40 minus X. So now you have got an equation in X. You can solve for X here fairly simply, and you will get the answer. And the equations are generally fairly simple in this one. You have 3 by X is equal to 5 by 40 minus X. So 120 minus 3X equal to 5X, 8X equal to 120, or X is equal to 15. Okay, so Arnav does 15 units per day and Bhavan does 40 minus 15, 25 units per day. So I was able to mentally solve it. You can also mentally solve it. You don't need to go and solve the entire equation. And so now we know the question is, in how many days can Bhavan working alone complete the work? So Bhavan does 25 units per day. He needs to do the entire 600 units. So the amount of days it will be is 24 days. So again, most of it can be done fairly easily, quickly. So this was just to give a flavor in case people don't know. I think there isn't anything very complicated to teach here, so I would not spend my time teaching anything very complicated. The few questions that I skipped over, you have the video screenshots of them. You can try and attempt them yourself, or wherever you come across a time and work question, now solve them and solve them with the intention of solving them within 90 seconds. If you find some difficult ones, feel free to ask, message me, or post on the group, and I would respond. But these are marks which you should not leave on the table. If you these questions are there, you should be able to get them. बाकी ठीक है, algebra नहीं हुआ या PNC नहीं हुआ या number system नहीं हुआ, it's fine. But this though is like this cannot. If you're missing this, it's criminal. If you prepared and still missed such a question, then there was no point preparing for the exam. So yeah. Anyways, if you have any feedback, etc., let me know. I went through it fairly quickly, and I will close now. I wasn't able to see some of your comments today. My Facebook acts a bit weird. Sometimes it shows me the comments, sometimes it doesn't. So I'll read them now. And if you have any other questions also, you can put them in the comments. I'll respond to them once we close this video. Okay. Thank you very much. Unless you have certain doubts, you can post them. I'll just hang around for 1 minute more in case you have any questions or doubts, and then I'll close this window. Thanks for attending. This was a short session, but then the topic is easy, so I didn't want to drag it a lot. It seems I made a mistake somewhere multiplying by 5. Uh, it is fine. But the thing was so easy that I wasn't really focusing on the calculation. I'll just correct it if I can find it. Acha, here, true. It was 2 hours. You need to be careful actually. This was my mistake. You need to be careful. 75 units won't be there. It will be more close to 45 into 5. This I can at least still simplify. 15 and 2. So 75 by 2 will be the answer. And then it becomes 100 minus 75 by 2, or 200 minus 75, 125 by 2. And then you can simplify, as I mentioned, that you can go ahead how many units and so on. Okay, thanks a lot. I will end this now, and the video will anyway be available. So if you want to revise something or ask some questions, feel free. Thank you.